So what does that mean from an innovation standpoint? And this is something that is near and dear to my heart because I think we're changing. And I think we're not necessarily changing for the better as an industry, we're changing for the worse. Even though I think that from perspective of the company that I run today, it's actually changing in a beneficial way. The semiconductor industry, I think we all believe, has been and will be driven by innovation. But the costs to innovate now are staggering. As you can imagine, I have a lot of friends and colleagues that are in the venture capital business, and several of them that I know, their firms have completely exited the hardware side of technology. Some have completely exited technology and are focused on bio or green tech type stuff, but the classical hardware and software they've backed out of. And the simple reason for this is the cost that has been driven by these excessive mass costs, design costs, the tools costs that we have. And it used to be that you could have a product, you could have a customer, and you could have some real revenue for less than 50 million US dollars invested in the company. And to syndicate through a few VCs, $50 million is not a big thing to do. It's a very reasonable amount. It's not nothing, it's certainly a lot of money, but it's very a feasible amount to have. Today, I know many of the companies that are not even close to products and have spent in excess of $250 million. And it's making it such a steep amount that it no longer makes sense for all but a few of the VCs to continue to invest in it. So I think the startups that have arguably driven our industry through innovation and have become the fantastic large companies either on their own or through being acquired by larger entities are going to be few and far between. So I think we're in a very different environment from an economic standpoint because the way that the industry created all of this innovation is going to be a challenge to continue to have happen. So it's going to have to fall upon other companies. And as I said, I feel this is not a good sign for our industry because I think the small dynamic startups are really not only fun to work with, but they don't have the overhead, the difficulty, the social issues of large companies in coming up with innovation. On the other hand, I feel that this positions my company rather well because we're a real-sized company. We have about 500 people, all engineers. So it's big, but it's a lot smaller than the stuff that I've run when I was at IBM and Lucent and Motorola. It's about $1 billion market cap, so it has enough currency to do things. We are very heavily invested in the IP where we can make a difference. Some of them that I told you about, the others that I haven't that are in labs. So I think we're making real innovation. And I think about our company today, even though we're publicly traded, almost as the startup of before. We're nimble enough to get things done. As I tell the team, it was very hard when I was in IBM, no matter how high I was, because there was such a huge amount of mass to move that it was challenging every day to see how you could make a difference, even when you were very high in management. On the other hand, every single engineer in our company today can make a difference. They can make a difference in one day in what they do in terms of setting the direction of the company, driving real value, and driving value in the industry. So I think it's an interesting implication for the medium-sized companies who are going to have to be taking up more of the innovation, even though I think it will be difficult. So what does it mean for those of you in the semiconductor design part in India? Certainly, SOC is critical, right? There is no way that we're getting around this. As I showed in the beginning part, the economic semiconductor underpinnings are still going to occur despite these challenges in the cost side of it. But the semiconductor IP creation are partnerships that you have to assure to be extremely successful. And lowest cost is going to be important, but the proportion of cost from the human side of it is going to be less. So when you're facing mass costs that, as we described, are $10 million, and tool cost to set up a team is $10 million. If the human cost for the team is $5 million or $10 million, it's still a lot, but the advantage that you typically have in India of 2.5 times is not going to be as great as it was before. So I think there is unfortunately an economic underpinning that is going to make low-cost design centers, right, only viable if you can drive exceedingly high quality through the products that you make, not just through low cost of human capital. So what is a broader implications for India on the technology side, at least in my opinion? I know as you look out that you see China is a very interesting competitor and a very dynamic company, and I think we all have to admit that the state-run capitalism has greatly benefited their company. They have outstanding infrastructure and lots of local strategic investment. You know, they've been propagating the U.S. Economy for a long time by bearing the treasury bills and allowing our consumers to continue to consume. So that has certainly slowed, but it has driven either a virtuous or vicious cycle, depending on your point of view. On the other hand, the semiconductor design has not been as fast. Certainly there are some great companies out there in China, but it's certainly not as propagating as they are on the manufacturing side or even some of the system side of the things that they've done. But I think that this changing economic underpinnings can level the playing field. And quite candidly, India, I think if bold enough, can take a true global leadership in design. Certainly are already that in software. And I think you can become that in silicon design if you achieve the high quality levels that I expect that you can. The keys for success are going to be developing that local demand, which is what you've talked about repeatedly, and I know you're going after, and not just performing low-cost outsourcing. So kind of a last slide before a little bit of vision stuff. If and when you invest in a fab, this is unsolicited input. The first part is, as I said when I met some of the team from the IESA before, is make sure the infrastructure is in place. I think everybody who's gone through building the fabs, as I have in different companies, this can be exceedingly painful. Don't forget about the semiconductor IP that is required. We've actually had some engagements recently with foundries where they have fantastic technology, but they were missing the IP. And attracting customers became incredibly difficult. So companies like ours would be glad to work more openly on creating the necessary IP for the foundries that India decides to put in place. And do not underestimate the time or the amount of IP that you will need. Companies like TSMC are number one. They're a near monopoly in their position in what they do. They have fantastic technology, very impressive company. But they also get the IP essentially made for free because everybody targets them in one way or the other, so the IP gets there. When you're wagging the dog, the tail wagging the dog, you should not expect the IP for free because it won't happen. It will be very challenging. The process node intercept, when you looked at the economic underpinnings as I was outlining there, and how quickly you evolve to advanced nodes, will also be something to take into account. Because maybe things are going to start stretching out longer and you will not want to go as quickly to the advanced technologies. On the other hand, if you fall too far behind, you are not going to be able to offer a point of differentiation, and you're going to be on the very low end fighting at declining costs. Because remember, once you've spent the money on the fab, right, it's over. It's all marginal cost. So the marginal cost to run a fab, especially when you have low-cost labor and chemicals that are already set up, is rather small. So it's a different part. And most importantly, quite candidly, if you can't fill it and be confident to fill it, as most fab managers know, don't do it, right? On the other hand, if you're going to do it anyhow, corresponding with the IP, which is the way you fill it, make sure you can find the internal demand to be able to make it there. So I felt, since this is a little bit of a vision thing, that I should probably end with a look at what's next, because I think there might be something here also towards some of the investments in design and infrastructure and fabs that India is probably going to make. This is I've used the different forms of this slide over the last 20 years. This is our great graphics. Our marketing department insists on putting it like this. I typically show it as an expanding bubble slide. And I start in the 1960s with the mainframe. And what this chart basically posits is that every about decade, there's a new theme that emerges in the industry, and this new theme is ever expanding in terms of economic breadth. In fact, I would say that semiconductor economics underpins everything that happens, from trading on Wall Street to making toys to making the cars that we do. It's so pervasive and underpinning it that it really drives everything. But these general themes tend to evolve with time, and if you look at them, the companies that I would put in the class as winning or leading that are often different. And I've been building this slide since I got out of university in 1990, and it hasn't really been wrong in any way, in part because of the ability to twist facts, as I said, for economics, but also largely, I think most people buy it. And last year, we added one part on here, the Internet of Things. I was a little skeptical of this. I ran, in the mid-2000s, a French company, publicly traded company. I repositioned it from doing chipsets and protocol stacks for GSM-based handsets to doing machine-to-machine applications. And the company was very successful. We grew the company, but I ultimately merged it with another company because there wasn't enough scale. So we were in what was the precursor to the Internet of Things, often called machine-to-machine or M2M. And it was a great industry. It was very positive. But there was a set of complexities that had not been solved. And there was tremendous economic issues, mostly along the lines of margin stacking, where there was too many people in the value chain or value web to be able to economically sort things out easily. And that created a slowness of the uptake, even though the technology was very interesting. Having said that, I think as we've moved over the last 5 years, things are a lot different. Today, you know that there's an enormous amount of data. I love this little wheel on the right-hand side that shows, right, the amount of data that is going through every minute of every day, the network. It's just staggering, right? And the ecosystem that has evolved is incredibly complex, but one where I think all of the participants are looking at the same factoids, the same economics, and driving to try to find a way to truly make what I think Intel called ubiquitous computing in the 1980s more of a reality today than it will be ever in the past.